This is going to be the topic of roots today. And today is 318. Okay. So we're going to take it back to like the basics. The first thing is that this here, this is a square root symbol. Okay, that symbol you've probably seen before, right? It's one of the main math symbols that are around. So that is a square root symbol. A square root is the inverse. Inverse means opposite of squaring a number or taking it to the second power. So again, a square root is the inverse of squaring a number. That means that I am going to be undoing the number being taken to the second power. Okay, so when my exponent is 2, we call that squaring something. And here's kind of why. Area of a square. So here I have a square. And the square has a side and a square has a side. So in this case, area equals S squared, side times side. Okay. So when we talk about the square root, a square root is like being given the area of a square and finding the side lengths. So if here's my square, all sides are equal. In order to find the area, I have side times side. When I write that out, it becomes S squared. If I take the square root of that, that basically means I'm breaking this apart and I'm coming up with what the side length is. So here's our first example. The square root of 25. Let me move that for you. Okay, this means, so this is one of the ways you can think about this in your head. Okay, that might help you to visualize it a little bit. So this means if the area of a square is 25, what is the side length? Okay, that's kind of like the picture and that you're trying to formulate in your head. So when we look at this, if I have this square here, right, and inside it, the area is 25. Then what I'm looking for is this side length and this side length. So remember, all sides are equal. So what two numbers that are the same multiply together to make that area? The answer would be 5. Thank you all. So the square root of 25 equals 5. Okay, so that is finding the square root. Now, square roots only work for numbers that are perfect squares, meaning that, again, to be a square, the side lengths have to be the same. So there are some numbers that are not perfect squares. And those numbers, we are not going to really learn how to find the root of, because we're only focused on square roots. Now, we are going to talk about estimating roots. So this is estimating roots. Estimating square roots. Okay. So if I have a square root that does not work out evenly, so square roots that do not work out evenly are irrational numbers. We'll get more into what like irrational numbers are later on in this unit. Okay, so when we are estimating roots, there are 3 steps. Step 1, find the 2 perfect squares that the number is between. To decide if the decimal should be big, small, or in the middle. Multiply until you find the decimal that is closest. Now, that's kind of hard to understand just as words. So we're going to do an example together so we can determine like what does that really mean? Okay, because that's kind of confusing to understand like what that's trying to explain. So here is the example. Now, when we are estimating roots, I want everyone to realize like this involves math that you need to do on paper, not in your head. Okay, this is multiplying and multiplying with decimals. Like we are not doing that in our heads. So we need to have work written on the paper. So let's say I have the square root of 79. Okay, square root of 79. And the question here is like, is this a perfect square root? Okay, so if you're like, I have no idea, then the first thing you're going to do is you're going to start to calculate things in your head, like 5 times 5, 25. Oh, well, that's way too small. 10 times 10, 100. 9 times 9, 81. Oh, that's close. So I have 9 times 9, that is 81, and I have 8 times 8, which is 64. I want to point out there that there's no number in between those, right? So this is not going to be a perfect square. So what we're going to do is we are going to write 64, the square root of 64, the square root of 79, and the square root of 81. And we're trying to estimate this. So this here would be 8 times 8. This here is 9 times 9. Is everyone okay with how I got that so far? Okay, so now what I'm going to do is I'm going to pause a moment and I'm going to think, is 81 bigger than 79? The answer here would be yes. So 9 is too big, which means that this number has to be 8 point something, right? It can't be 9 because then I'm too far over. So it has to be 8 point something. Now that's something I need to figure out. So when I take a look, I'm going to think to myself, is 79 closer to 81 or is 79 closer to 64? Well, it's going to be closer to 81. So now when I'm choosing my decimals, I'm going to choose decimals that are closer to getting me to 9. Okay, so I'm going to just start off with multiplying 8.8. So here I have 8.8, and I'm going to do 8.8 times 8.8. I understand that what I am doing might be strange, but this is what I'm going to do today. So if you want to multiply yours differently than me, go right ahead. That's fine. Okay, so I came up with 77.44 or 77 and 44 hundredths. I'm trying to get to 79, so this is still a little bit too small, right? This was 8.8. Okay, that's a little bit too small. So my next decimal would be 8.9. And I got 79.21. So when I look at these, is 79.21 closer to 79 than 77.44? Yes. So then I know that 8.9 has to be the closest number to finding the square root. So I would put here the square root of 79 is about, whoop, there we go. Okay, everyone see these squiggly equal signs? That means about. That means you're estimating. It means it's not exact. If you put a regular equal sign here, I will mark it wrong. Someone hear me say that? When we're estimating, you need to use the estimation symbol. And then this would be here, 8.9. Okay, so that there is estimating square roots. Okay, and then we have one more thing that I'm going to squeeze in today that is different than a square root. So a square root means that I just have the basic radical sign or the square root sign. Sometimes we will be calculating larger roots than square roots. So this is calculating cubic roots. Calculating cubic roots. So the term root in math is the inverse of a power or exponent. So what we just talked about was this here reads the square root of 49. So again, what two numbers multiply together to make 49? So this would be equal to 7 because 7 times 7 equals 49. Okay. Now, this here is called a cubic root. So if it is a square root, which this symbol represents, there's nothing inside here. Does everyone see that? There's nothing inside there. However, when I am solving for other types of roots, like a cubic root, the index changes and I have a 3 there now. And that 3 lets me know that I am trying to find, instead of 2 numbers that multiply together to create what's underneath my radical, I need to find 3 numbers that are the same that multiply together. So let's say I'm trying to find the cubic root of 8. So one of the things you could do is, if I was to write it out like this, the cubic root of, I'm going to try to write 8 as a product of primes. So that means prime numbers that multiply together to create 8, which I happen to know is 2 times 2 times 2. So then the cubed root of 8 is equal to 2. This is what your answer would be. So then when we take a look at this, let's say I have like the cubed root of 125. So this would be equal to the cubed root of 5 times 5 times 5. So the cubed root of 125 is equal to 5. Okay. One of the things that I forgot to touch on, which is really important, so I'm going to go back actually a couple pages, and I'm going to come back to this, the area of a square and the square root sign. Now, when we're using the idea of a square, it does not make sense for a side length to be negative. I think we will all agree with that, right? Like I can't have a negative distance. I can't have a negative side length of something. However, the square root symbol is showing that it's two numbers multiplying together to make 25. So anytime I have a square root, the numbers come out and they're not necessarily positive only. So what we would actually do is we would say here, I'm going to just squeeze it in right here. The square root of 25 is equal to plus or minus 5. Because I want you to think about this. If I had -5 times -5, I still get a positive 25. If I have 5 times 5, I get a positive 25. So anytime we are solving for the square root of something, the final answer is plus or minus that number. Plus or minus. Now, if it is asking me for the square root of a distance, remember, I can't go a negative distance. So in that case, it's going to have to be the positive. So sometimes you might need to interpret it based on the question. But in general, if we are simply solving for a square root, we're looking for an answer that's plus or minus the number. Now, the reason for that, I'm flipping back now to cubic roots. The reason for that is because squaring means that I have a positive, I'm sorry, an even amount of integers, right? So I have an even amount of negatives. So it has to end up positive. But when I have a cubic root, so a cube root of a number, so when I'm solving a cubic root, a cube root of a number is one of its 3 equal factors. Okay, and we saw that up above, right? Right here, I have 3 factors, so my cube root is only one of them. So because cube roots have 3 factors, that's an odd number. So if inside here it's a positive, my answer is no longer plus or minus because it only can be created by having a positive number. If I have like the cubed root of -27, the only reason this works is because we are solving for a cubed root. I cannot multiply 2 numbers together in a square root to get a negative. So if I was to write this out, the cubed root would be like -3 times -3 times -3. -3 times -3 makes +9. +9 times -3 makes -27. So the cubed root of -27 is equal to -3. Okay, so that in a nutshell is roots. That was a lot of information. So this video will be on the weekly in order to help assist you. And then obviously, if you have any further questions, always come to SGI to get some help or ask in class.